A frozen pizza on a kitchen counter looks like a simple convenience, but that box is the final output of a multi-billion-dollar logistical system. Every pizza is a composite of water, proteins, starches, and fats. At sub-zero temperatures, each component reacts to the cold according to its own chemical nature. There is a common assumption that a standard domestic freezer acts as a pause button for biological decay. We assume that dropping the temperature simply suspends the ingredients in their current state. In reality, standard freezing initiates a slow physical reaction that guarantees the structural ruin of the food. This gauge identifies the window of maximum biological damage. Food scientists call the range between -1 and -5 degrees Celsius the critical zone. Lingering in this zone forces water molecules into large, jagged ice formations between the cells. These crystals expand and physically slice through the cell membranes. This cellular rupture makes slowly frozen dough mushy and destroys topping texture. Delivering a high-quality product requires an industrial system capable of bypassing this microscopic destruction entirely. That process begins on the factory floor, where the speed of the assembly line is engineered to outrun biological degradation. The dough is measured by its W force, a specific metric of elasticity. This ensures the crust can survive high-speed automated shaping without tearing. Once the base is set, automated systems apply sauce, cheese, and meats at a rate of 45 units per minute. This requires marrying wet and dry ingredients across a moving, uneven surface while maintaining precise weights and coverage. The goal of this automation is to fully assemble the product and move it to the freezer before room temperatures can trigger the first stages of decay. The assembled pizza is immediately moved into the most hostile environment on the production line, the blast freezer. A blast freezer utilizes hurricane force air circulation running at -40 degrees Celsius to strip heat from the product as fast as possible. This thermal assault causes the pizza's temperature to plummet. On this graph, the line drops nearly vertically, bypassing the dangerous critical zone. Because freezing is so fast, water molecules form microscopic crystals entirely contained within the cell walls, leaving the tissue intact. At this point, the structural integrity of the food is locked in place. Time is officially paused. Once the product leaves the factory, it carries a permanent physical record of how it was frozen. To maintain this state, it enters a massive cold chain. This network of insulated trucks and automated warehouses is designed to keep the product at a steady sub-zero temperature. The primary threat here is Oswald ripening. If the temperature fluctuates when a truck door opens, the small ice crystals begin dissolving and merging into larger, jagged formations. This recrystallization process is irreversible. Any break in the cold chain permanently degrades the cellular benefits of the original blast freeze. The logistics network acts as a defense mechanism to preserve the state of the food until it reaches the consumer. The final stop is the supermarket freezer aisle. Because of the energy required to maintain these temperatures, this is some of the most expensive real estate in the retail industry. Retail viability is governed by Fourier's law, which states that the rate of heat extraction is dictated by the physical geometry of the object. A flat, rectangular pizza box allows heat to escape quickly, compared to a deep cylindrical tub which traps heat in its center. This flat shape also maximizes stacking density on the expensive freezer shelves. The packaging and barcodes integrate each unit into a digital inventory system that tracks the product through the final mile of the supply chain. The cardboard box is a thermal vessel engineered to protect the product's quality until it reaches your oven. When the pizza is placed in a home oven, the heat reverses the freezing process, turning the ice crystals back into liquid water. As the ingredients rehydrate, the pizza returns to the state it was in before it entered the blast freezer tunnels. This transaction allows the consumer to trade the cost of the pizza for the specialized labor, global supply networks, and industrial preparation required. While it appears to be a simple convenience meal, its quality depends entirely on the precise control of sub-zero thermodynamics. When you buy a frozen pizza, you are purchasing the result of an industrial system built specifically to stop time.